Alrighty, here's your video for your 4 little question review. Remember that there is stuff in Delta Math and AP Classroom. Be prepared for this. Okay, let's look at number 1. It says using the substitution. So we're using U substitution, and it tells me what U is. So I can come over here and say, all right, U is equal to the square root of X, which is the same as X to the 1/2 power. It's probably better that it's written like that. And then I'm going to find du. That is going to be equal to 1/2 times x to the negative 1/2 power dx. Do not forget to write that when you are showing your work on this stuff, because it makes a difference. All right, so what this really is, okay, another way I can write this is 1/2 times 1 over the square root of x dx. When I look over here at what I have, this square root of x is in the denominator, so that's like my 1 over x. There's the dx, but there is no 1/2, so I need a 1/2 in here to make that work, which means I need a 2 on the outside. So what that leaves inside of here is this e to the x. All right, so when I have that, I know what u is. U is the square root of x. So that's going to become e to the u. Now, here's something that I've saw quite a few of you make this mistake on. Here's my integral symbol, right? The 2 goes out here. I am not writing the 1 and the 4. This is going to be e to the u du. Okay? Now, I do need numbers there, but now this stuff is in terms of u, so I need to say when x equals 1, u equals the square root of 1, which is 1. When x equals 4, I'm getting these numbers from here, then u equals the square root of 4, which is 2. So that means I'm going from 1 to 2. And that is my answer, which is C. Okay. So this one was actually on your last review, but I did it differently because we hadn't done these all these integration techniques yet. But I can split this up. I'm still going to split it up like we did before. I want to integrate going from 1 to 5, but this is a piecewise function and it gets broken at 3, so I need to break it into 2 pieces. So I'm going to integrate from 1 to 3, and then I got to figure out which piece goes from 1 to 3. Well, when x is less than 3, so that would make sense. So I'm going to integrate 2 dx. Plus, I'm going to integrate going from 3 to 5, this part, this x minus 1 dx. Make sure your notation is correct. I understand that this is only a multiple choice question, but not all questions are multiple choice, and some of y'all have some sloppy notation here, and I don't want that to become a habit. So now I'm going to integrate. And I don't feel like I need u substitution or anything like that. Now, there is a different way to look at this part, and I will talk about that part. I'll talk about that when we get done in just a minute. But if I integrate 2, that becomes 2x, and I'm going to evaluate it from 1 to 3. And then I'm going to add to that when I integrate this part. When I integrate x, that becomes x squared over 2 minus x, and I'm going to evaluate that from 3 to 5. Now, at this point, to maybe be a little bit safer with signs and stuff, you could split this into 2, like do this part and then do this part and then put them together. Just be careful how you're doing that, but you want to be careful with your signs here. When we are evaluating, okay, I'm going to evaluate this one going from 1 to 3, so that means I substitute in 3 first, so 2 times 3 minus 2 times 1. That's this part. Plus, now I'm going to evaluate this. I'm going to substitute in 5 first, so I'm going to get 5 squared over 2 minus 5, and then I have to subtract, and then I substitute in the 3. This is more than one term. You need parentheses here. This is going to be 3 squared over 2 minus 3. Okay, now, yeah, I got some fractions, but I don't really have to do a bunch of weird common denominators here. I'm just going to clean this up a little bit, which I could have done in this step, but it's kind of safer that I didn't. Let's just clean this up a little bit. Let's get 6 minus 2. I know you can do that, but I'm just going to clean it all up. Plus, then this is going to be 25 over 2 minus 5 minus 9 over 2 plus 3, because I have to distribute that. That's something that could harm you in all of this. And so now I'm going to combine stuff. So I know that 6 minus 2 is 4, minus 5 is a negative 1, plus 3 is 2, and then 25 over 2 minus 9 over 2 is going to be 16 over 2, which is 8, so that's 2 plus 8, which is 10. I mean, you could have got common denominators and all of that, but sometimes things just work out where you don't have to do all of that. But be careful and don't lose yourself in this is, no matter how well you understand this, there are so many places in there to make a sign error or do something weird. So be very careful and diligent with your work and your notation. Okay? Okay, so on number 3, I'm going to integrate, okay? And a good way to do these is to start off by just kind of assuming that it's u substitution and see if you can find a u. So as I think through this, okay, I feel like there's 3 basic things I could use as u. I could use 6x, or I could use the sine of x squared, or I could use x squared. Well, if I do 6x, and then I take the derivative, that's just a 6, and I don't see how that's going to help me. If I do the sine of x squared, then when I take the derivative, I end up with a cosine. There's not a cosine in there, so I'm thinking that's not going to work. So then the x squared, if I take the derivative of that, that's 2x, and I have a 6x. I feel like I can make that work. All right? So I think that's what I'm going to try. And remember, sometimes you might try it, and then it just don't work, and that's okay. All right, so I'm going to say that my u is going to equal x squared. That means du equals 2x dx. All right. And then I can go ahead and I don't need to worry about my limits of integration, the numbers here, because there aren't any, so that's totally fine. So I have this. Now I'm going to say this is going to be the integral. Well, this is 6x, this is dx, this is 2x. So I have been multiplying stuff in, like doubling it or whatever, but I need to make this 6x into a 2x, which means I need to multiply by a 1/3 in here, which means there's a 3 out here. Okay, so the 6x dx 1/3, that's what this is here, so that's my du. And then this is going to be the sine of u du. Now, it would be difficult to do it here, but just because of the nature of the answer choices, but one of the mistakes that I've been seeing also is u substituting in the u and knowing you're supposed to do u substitution, but then not actually integrating, because you're kind of using the substitution part as the integration, so be careful with that. So when we're thinking about sine and cosine, we know it goes sine, cosine, negative cosine, right? So going this way is derivative, going this way is the integral. So if I'm going to integrate sine, I have to go up, which means I wrap back around here to get negative cosine. So this is going to be negative 3 cosine of u plus c. Okay, so I have the plus c because I don't have limits of integration. I substitute u back in because I don't have limits of integration, and that's what's going to make it c. Okay. All right, so on number 4, I think we're going to do, try this u substitution. Usually what you're looking for, and even up here, the things we're looking for is maybe what's inside of a parentheses or what's in the denominator, or, if a function is inside of a function. So I think here we can go with the denominator. So I'm going to make this, I'm going to make u equal to x squared plus 1, which means du is equal to 2x dx. Don't forget the dx. And then somebody asked me today, would it be good for me to go ahead and do the limits now? Yeah, probably, so that you don't forget to do them. So then I can say if when x is negative 1, not x minus 1, my goodness. When x equals negative 1, then u is equal to negative 1 squared plus 1, which is going to give me 2. When x equals 2, then u equals 2 squared plus 1, which is 5. Okay, so I know now that when I go to do my integral, I'm not going from negative 1 to 2, I'm going from 2 to 5. All right, my du was 2 dx, so I have x dx, I'm sorry, it's 2x dx. So that means I need a 2 in here and a 1/2 out here. So that's a 1/2 out here. And all that will be taken care of with the du, which means I just have u right here. Now, I got this from a few people that said, I really just don't feel like that's right, and I just don't feel like I can write that. You can write that, and it's totally fine, but the reason I think it's not making sense to you as much is because there is another way to write it. 1/2 times the integral from 2 to 5 of 1 over u du. So just rewriting it that simple can really make a difference. Now here I did see from more than one person at this point kind of drop the integral sign and start evaluating and then wonder where the heck did the natural log come from? Well, that's because you didn't actually integrate. Remember, you have to integrate and your notation has to be correct here. So when we do this then, I'm going to have 1/2 times, well, when I integrate 1 over u, it becomes the natural log of the absolute value of u. I don't need a plus c because I have limits of integration, and I'm evaluating from 2 to 5. Okay? And I'm not substituting back in the x squared plus 1 because I changed my limits of integration there. So then this is going to become 1/2 times the natural log of the absolute value of 5 minus 1/2 times the absolute value. Oh, sorry, that's not the natural log of the absolute value of 2. Which we don't have an answer choice that looks like that, so we have to figure out algebraically what we need to do. Well, these both have a 1/2 in them, so I can factor out my 1/2. And then when I do that, this is the absolute value of 5 and absolute value of 2. I can drop the absolute value signs because that's still 5 and 2, because they're not going to change that variable. So natural log of 5 minus the natural log of 2. Now, then we have to know a log property. But let's just use a little bit of logic here as well. We know, or at least you should know, that the natural log of 5 minus the natural log of 2 is not the natural log of 3. That's like saying the square root of 5 minus the square root of 2 equals the square root of 3. We know that makes no sense. So this here is not going to give me the natural log of 3, so my answer is not B. The other thing is the natural log of 1 is 0. Natural log of 5 and natural log of 2, if you don't have a good idea of what they are, that's fine, but you should know that neither one of them are 0, or they're not going to be the same where they zero out and you multiply by 1/2, so that eliminates this as well. So these are the only two choices I have, period. And then to go from there, we have the 1/2, so we should be good with D. Now, but let me remind you of what the rule actually is. When you have two logs with the same base and you are subtracting them, you can condense them to one log with that base, and you change that to division. If this had been addition, then it would be the natural log of 10, because you condense it and you multiply. Okay, so yes, you have to know some log rules, but if you don't, you can kind of reason through your answer choices as well. You have lots of tools in your toolbox. Don't let your brain shut down on you and not be able to use those tools. And don't forget, you have stuff in AP Classroom and you have stuff in Delta Math, and you can come see me during math time tomorrow, but make sure that you are actually prepared for this test.